Chapter 2, Section 2.3, Math 110. Here we have this graph, and they want us to use this graph to find the domain and range. So if you recall, domain is for the x value and range is for y value. For instance, if I have a graph that goes like this all the way, goes to positive infinity, and here goes to negative infinity, that means as far as the domain or as far as the x, it goes all the way toward positive infinity and all the way toward negative infinity. So domain, where the x value extend, is from negative infinity to positive infinity. How about the y value? Y value is the range. In the case like this, the graph does not go below this point. So the y value goes all the way from 0 up. So like any point here, look, this is the y value. So range is from 0 to infinity. You don't have any negative number for the range. So the range is 0 to positive infinity. Or if you have a graph, let's say it's like that, again, x or domain goes all the way to positive infinity, and this goes to negative infinity. But the range, which is the y value, is from here down. So if this is like 5, goes all the way from 5 to infinity. So the range is what? The range for this one, the range is from 5 to negative infinity, right? Because this goes all the way to negative infinity, and the top is positive infinity. And what's the domain? Again, domain is all the way from negative infinity to positive infinity. So based on that, in these problems, the domain, this goes all the way to positive and negative infinity. And the range, the function starts from here and goes up. So it's not below -4. You don't have any curve below -4. So the y value or the range is from -4 to positive infinity. You don't have to even put positive infinity. If you just put infinity, it means it's positive. All right. So what is f of -2? Remember, f of -2, what does f of -2 means? Means when x is -2, what's the value of y? So on the graph, you go and find -2, okay? And what's the y value here? 0. F of -1, when x is -1, on the graph you find this point, x is -1. What's the y value for it? It's almost like -1.125. If you want to know the exact one, I think graphing calculator would tell you. What about x equal half or 0.5? It's here. This is 0.5. And what's the y value? Since it lies on the x-axis, y value is 0. F of 1, when x is 1, see here, and what's the y value? It's minus 2.625. I think, again, if you want to know the exact number, you need to use the graphing calculator. When you graph in calculator, when it graph it for you, if you put the function trace, that will give you exact number. F of 2. F of 2 again means when x is 2, right here. When x is 2, what's the y value? 0. F of 1, when x is 1, now at 1, there are two y value. One is 4, one is -4. You take the one that is 4. This circle, when it's filled, means when x is 1, y is 4. The other one, the next line is start a little bit more than 1. It's like 1.01. So when x is 1, you pick the one that the circle is filled. So like for this one, when x is 1, y is 4. F of 3, this is 3. So you go up, and then you read your y value is 4. F of -1, see this is -1. So when you go up, what's the value of y? It's 6. So for any of these numbers, you find the x and you draw the vertical lines, and then you go horizontal to find your value. Use the vertical line to test what is the functions or not. Remember, what you do is you just take the vertical line, start from right to left. I can even use the DL so you can see it better. You use the vertical line, intersect the graph at only one point. Intersect at only one point. So if the vertical line intersect the graph at only one point, then this equation is a function. Yes. We talk about it on section 2.2. So if this is a vertical line test, you have a vertical line and you move it from left to right. On this one, you do a vertical line. Vertical line intersect the circle at 2 points. See? If intersect at more than 1 point, then it's not a function. So this is a vertical line test. We do that test if you already have the picture and we ask you to tell whether is the functions or not. Now, they are asking us to solve these equations. Find the zero of the function. Again, what does that mean, zero of the function? Zero of the function means that y has to be equal to 0, and you solve it for x. So for that problems, the best thing is to use the quadratic equations. You identify your a, b, and c. This is a formula. You take all the numbers and plug in the formula, and I have two answers, 7 and minus 7.5 or minus 3.5. So when we say f of x equals 0, means y is equal to 0, means the whole function is equal to 0, and you solve it for x. This is if we ask you to find the x-intercept. Sometimes we ask you to find x-intercept. When we ask you to find x-intercept, means you got to take the y equals 0. Because what's the y-intercept? Y-intercept is when you have, let's say you have a graph, and it's like this. These are x-intercept, right? Where your graph intersect the x-axis. All these points, they don't have any y. Y is 0. And then you have to find the x value. So when we give you equations like y equals x2 plus bx plus c, and we ask you to find all the zeros, means set y equal to 0. When you put y equals 0, means solve these equations, which we are using the quadratic equations. And that's how we have it here. Second problems, find the zero of the functions means you take that, this was y, right? You set it equal to 0. If you write 0 over 1 and you cross multiply, 0 times all this is 0, and x times, so x is 0. So for this one, when f of x equals 0, means x. Now, how about this one? Find 0 of this function, means you take the whole thing and you set it equal to 0, and that's what you have here. Now, when you take the whole thing and you set it equal to 0, we use group factoring. To use the group factoring, there are 4 terms. You split into 2 different groups. And the first one, x3 and x2, they both have x2 in common. You take the one that has a lower power, is x minus 3. When you find the parentheses here, you don't have to really worry about factoring the second one. What you do is you take these parentheses and you put it here. One of the advantage of group factoring is when you find the first parentheses, you just take it and put it here. All I need to do is find what number I should put here, that when I multiply by x, it gives me minus 16x, and that's minus 16. So they both have x minus 3. When I remove x minus 3, what is left? x2 minus 16. Now, x2 minus 16, then remember this formula. The difference of 2 perfect square is a minus b times a plus b. So we use that idea for this problem because 16 is 4 to the power of 2. So now you end up having 3 parentheses. You take each parenthesis and set it equal to 0. That gives you 3 numbers. These 3 are 3 intercept. So when you graph these third-degree equations, at 3 places, your graph intersect the x-axis. Now this one, they're asking us to use the graphing calculator. So you need to be familiar with graphing calculator, especially for some of the problems are very complicated if you want to use hand calculation or take some points and plug into the formula. So here we have find a zero. Again, find a zero means take the whole thing and set it equal to 0. When you solve it, x is minus 17 over 4. And they ask us to graph it. If you want to graph it in using the calculator here, on this one, I already put the function here. Look, you put radical and then 4, 4, and x is here. Xt is 4x plus 1. And then you graph it. Okay. So that take care of that problem. Now they're asking you to find the interval the function is increasing, decreasing, or constant. You know, when you have, let's say you have equations like this. And you have a graph that this graph, say it starts from -5, it goes up, and then goes down, and then it's like this. So between -5 and 3, what happened between -5 and 3? Function increasing, right? What happened between 3 and 6? Decreasing. The reason I have one parenthesis, one bracket, because 3 cannot be on both sides. So if you say from -5 to 3 is increasing, right after 3 is like what, 3.02? From there, the function decrease. And then right after 6, when x is greater than 6, then function is constant, okay? It doesn't decrease or increase or decrease. That's the same idea that we use. So here, the function always increase. See that? So between -infinity and positive infinity, function always decrease. For infinity, you never use bracket because we will never reach there. So it's always goes from -infinity to positive infinity. So D and E, we are using this means is do not exist. Does it decrease? No. Does it constant? No. It's just increase. It comes from -infinity and goes all the way to 0. So from -infinity to 0 is increasing, right? Go from minus infinity to 0, and then again start increasing from here. So again, from 6 to positive infinity, increase again. And anytime you have two separate sections, you could always connect it with the symbol of union. Union is just two connections. So it increased from here to here and here to here. Decreasing from where? From 0 to 6, see here. And there's no constant. It never go horizontal or vertical. So that would be, does not exist. So from here to here, function increase, and here to here, function also increase. So when you see an empty circle, means is not 2, is a little bit greater than 2. So how do I write the increase for this? Increasing is goes from, it comes from minus infinity and goes to what? 0. From minus infinity to 0, and then increase again from here to infinity, to positive infinity. So this is 2, right? So it would be 2 to infinity. And then you put a union to connect it. Is there any decreasing here? No, it doesn't have any decreasing. So this would be, does not exist. What about constant here? From 0 to 2, from 0 to 2 is constant. So again, when you see an equality sign here, means 0 also is included in this one. So that's the difference between a circle is filled in or blank, blank. They want you to use the graphing calculator, take all these numbers. If you don't want to use a graphing calculator, what you need to do is take all these numbers one by one and substitute for x and find the y value to come up with these numbers. You could practice that one. So I did type the second one. When you graph it, you see both pictures, but if you don't want to see the first one, You just put this arrow to the left and enter. When it's flashing, then it doesn't graph that anymore. Okay? So now let's see how it goes. So just show the second one. You have to play with the window because it looks like a straight line, but it's not a straight line. But you know what? What they're asking here is they want us to find like minus 49. They want us to put minus 49 for the x. Put minus 49. For that, you don't really have to have a good graph. It just, I'll put a trace. And then I type minus 49. Oops. Oops. Well, I have to size the window in order to come up with the right value for that. The reason I think because x is 49 is a very large one. So this means you have to transfer 49. Like, you know, what's the difference between, if you want to graph radical x is like this, right? But what is radical x minus 49 means you gotta move it 49 unit to the right. So in that case, the scale on the window, I change it to, instead of minus 10, and normally it's minus 10 and 10, I change it to minus 50 and 50, okay? So now when I graph it, you have a better one. Now on this one, I need to find minus 49. When x is minus 49, what's the f of x? So here, trace, and I put minus 49, I do it again for you, minus 49. When you enter, it gives you 9.89 for y value. So you put that number here. It's 9.899. How about negative 1? Negative 1, enter, 7.07. 7.071. 0, well, we don't have to use that one. 0 is what? When you put 0 is 7. It's radical 49 is 7. 1, let's try that. Let's try 1. 6.928. And when you put 49, you know that when you put 49, radical 49 minus 49, and radical 0 is 0. Well, let's just try that. 49. See, it gives you 0. Okay? So that's is of that. I think one of the reasons they want these problems for you, see how you could use the calculator and come up with all these numbers. Now, what is relative minimum and relative maximum? Here, let's see if I have it here. So the best thing is for you to graph the equations. When you graph the equations, see, when you have, this is just the example. When you have something like this, there are some maximum and some minimum points. These are minimum and these are maximums. And this is on page 191, relative minimum and relative maximum. So the best thing is to find it. If you look at these examples, like in this one, there's just one. So you need to use the graphing utility to find the relative minimum of the functions, okay? And this is a good one to practice for you because you already have the solutions. So, so it's a time consuming for me to input all these numbers, but when you do that, you should come up with 0.2 and minus 8.20. And for the maximum, it does not exist because you don't see it. No, maybe I can go ahead and do this one. It's 5x2, so it's 5 x to power of 2 minus 2x minus 8. So if I don't want to show the other one here, let's see how it goes. Okay, let me change the windows here. Make it minus 10. Okay. So if you notice, there is just one minimum here. You see that? It doesn't have any maximum. So if I trace it, when x is 0, it's minus 8, but we have minus 820. That means that's not completely the minimum. Minimum is a little bit, but it's just jump. This is very tough one to do. So it's almost 0.2, but there is no maximum. Okay, we do the same thing for these problems too. So I'll come up with 2.79 and minus 8.21. We practice that. Minus 0.12, 4.06. Should be very close to that. They ask us to graph this one. This is very easy. You could just do your hand calculations, really. Let's say the best thing is to use x and y intercept, you know? Means I'll put 0 for x, y is 8, or put 0 for y, 8 is 8, 8 and 8. So it would be something like this, 8, 8 and 8. So then you just connect these 2 points. Okay, so that's an easy one. I don't know why they have this one here. But anyway, determine the interval for which f of x or y is greater than 0. Y is greater than 0 is this, right? Because f of x, see, f of x greater than 0 means y, because y and f of x are the same thing. Y greater than equal to 0 from here, right? Goes here. So what interval is that? Is from minus infinity to 8. It comes, see, the y comes all the way from minus infinity, comes from here, goes up. Okay, the next is rate of change. The word rate of change basically is the slope. And the formula for slope, oh, we skipped the 16. How would I graph this? X minus 9. Which one of this graph is correct? It's just you have to shift radical x 9 units to the right. 9 units to the right. And determine the interval for which y is greater than 0. Y is greater than 0 from what? From 9 to infinity. So from between x to 9 and x to infinity, y is increasing. Okay, it goes all the way to positive infinity, and here is from 9. So it would be 9 and infinity, the value of x. Now find the rate of the change, number 17. Okay. These 2 problems both ask us to find rate of the change from x1 to x2. And we mentioned rate of the change. What is rate of the change? Is slope. This is the equations, and this is x1 and x2, right? So for you to find y1 and y2, you got to take one by one each of these and plug it into the equation to find your y. So we do that first. When I take 0 and substitute here, y is 12. And then if you take the other one, 3, and substitute for the x, is 0. Then you put it in the equation for a slope. That would be -4. So again, rate of the change, in fact, is the slope. The second one, they're asking you to use 1 and 4, and this is your equation, and that's how you do it. Sorry. Oh, oops, I can't. There were in page 192. See that page 192? That's rate of the change. So f of x2 minus f of x1 over x2 minus x1, or y2 minus y1, x2 minus x1. See, that's rate of the change. So you find the slope, difference of y divided by difference of x. And there's another example here you could study here. Okay. Okay, next one is determine whether a function is even, odd, or neither. When you have the functions like this, why do we call this even function? Because let's say x is 1 or positive 1. What's the value of y? 1. X is negative 1. The value of y doesn't change because negative 1 to power of 2 is 1. See? Or let's say x is positive 3. Y is 9. X is negative 3 is 9. So you switch x to negative x. Does the y change? No. That's the even functions. All the even functions are like this. Look, x4 plus 5x2 minus 3. The power is always even numbers. So that's the even functions. Let's look at this one. This is odd function because let's say here, x is negative 2. Negative 2 to power of 3 is what? Negative 2 to power of 3 is negative 2 times negative 2 times negative 2. So it's negative 8. What if x is 2? Then y is 8. See? So when you change x to the negative x, what happened to the y? Y also changed the negative. That's the odd functions. And this is even. Like y equal 7x x5 minus 2x3 plus x1 minus 5. See, this is an odd function. They all are odd numbers. What if you have something like this? Y equal x4 minus 3x3 plus 2x. This is neither odd nor even. See? So you have neither odd nor even, or odd or even functions. All right, so this one, they all are 2 and 6, right? So it's even. Is the y-axis symmetric? Why? Let's think of the simple example. Y equal x2 is the even function, right? This even function is symmetric to y-axis. You see, if you change x to negative x, y doesn't change. So all the even functions are symmetric to y-axis. Because this is a y-axis, right? And what they show here is they are changing x to the negative x. They are changing x to the negative x. They want to show you that the function doesn't change. The y doesn't change. See, they put minus x here. Minus x, since the power is even, they end up having the same equations. So that's one of the property of even functions. How about this one? Origin, symmetry, and this is the odd functions. So you have to actually graph it to see it. But what happened if I change x to the negative x? What happened to the y? See? What's the difference between these two? Y changed to negative y. You see that? It goes from positive to negative. Same thing. That's why it's odd. So odd function is when you switch x to the negative x, y also change to the negative, opposite. Now, when you graph it as far as symmetric is, this is the origin. And unless you graph it, you cannot actually see it. It's like this one. Let me give you a simple example, like x to the power of 3. See? Like this function, this is another example. Any point, when you connect it to the 0 and reflect it, they fall here. So that is to the origin. Again, this one needs to be graphed in order for you to see it. Y equal minus 3. On the y-axis, you find negative 3. That's the graph of y equal minus 3. Is even. Why? When you change x to negative x, let's say x is 3 or x is 5. When x is 5, what's the value of y? Minus 3. When x is 5, what's the value of y? Minus 3. When x is negative 5, what's the value of y? Negative 3. See, y doesn't change. Okay? So that's property of even functions. So all the horizontal lines are, in this case, are even functions. Which one? You know, you could always put some numbers here, like, you know, what happened when y is 0? Or what happened when x is 0? When x is 0, y is minus 0 minus 5 or minus negative 5 or minus 5. 0 and negative 5. Which one has 0 and negative 5? X is 0 and y is negative 5. 3 of them. But this one, let's see what happened when y is 0. We could ignore the negative. X is 5. The only one who has that property is right there. So that's the answer. And the function is not neither nor odd, because you could try it. You could change the x to negative x and see what happened. Like you put, let's say x equal 3. You put 3 here, and then you put negative 3. If the y change is not even, or if the y does not give you opposite, you come completely different ones, then it's not odd either. Okay. So like for this one, let's say x is 3. When you put 3 here, what happened? Absolute value of 3 minus 5 is absolute value of minus 2, which is 2. So you got negative 2. When x is negative 3, what happened? Negative 3, negative 5 is negative 8. Absolute value of negative 8 is 8 is negative. See, you come up with 2 different numbers. So is neither of them. The radical negative x is this. This is a function of radical negative x. And then you shifted 6 units. You shifted 6 units to the right. So that gives you this one. Or you could always take some numbers and substitute. You know, that's well, like here. What happened here? Here, there is no x. X equals 0. When you put 0 here for x, y is what? Radical 6. Radical is 2 point something is right there. That's how you could tell which graph is correct, by plugging some numbers. And this functions is neither even nor odd for the same reason. You could always try some numbers, like as I said, you could just say x equal 3 and negative 3 and see what happened to the y value. Why does it, if y does change, then it's neither one. All right, so that would be end of 2.3.